we will, with the panel of authors from the commentary after our main presentation. We'll be opening up the chat box in a few minutes for questions that you may have of our panelists. Thank you again for being here. Next slide, please. CAST was formed in 1972 to provide a balanced, credible science-based information about food and agriculture to policymakers, the media, private sector, and the public. CAST is a membership-based nonprofit organization comprised of scientific and professional societies, other nonprofit organizations, universities, companies, and many individuals. Next slide, please. Through our network of experts, members, and member organizations, we select our topics for CAST papers, as well as access to a network of scientists, economists, engineers, and other subject matter specialists who help produce these papers. Next slide, please. CAST has a small office in Ames, Iowa. Much of the work that CAST produces is through volunteers who serve on our boards, the governing boards, task forces that compile and write our papers, and reviewers that make sure our papers are unbiased and based upon sound science. Over the past 13 years, we've involved over 1,000 subject matter specialists who graciously volunteer their time, energy, and expertise to help us accomplish this work. Next slide. Our publications and information are intended for audiences of policymakers, the media, private sector, public, and educators. We do this to increase the accessibility, awareness, and understanding of the science, technology, and innovation so critical to food and agriculture. Next slide, please. If you visit our website, you will see we have several different types of CAST publications. Our most popular are CAST issue papers and CAST commentaries. We also produce an Ag Quick Cast for each of our papers that serves as an easy to access executive summary of the key information. We've recently introduced a student study guide, which we hope will be used by teachers and students to learn more about the current food and agricultural science issues. Listed on our website are other CAST papers that we'll be releasing over the next several months and through the rest of 2020. Next slide, please. The use of social media is an important part of our science communications efforts, and I invite you to join us on any of those platforms. Just a reminder that today's webinar is being recorded. Toward the end of our main presentation, we'll post a message that the chat box is open and for you to submit any questions that you may have of our panelists. Next slide, please. Like most of our publications, this paper was compiled and written by a task force of volunteer subject matter experts. The task force chair is Dr. Robert Collier. Dr. Collier is the head of Animal and Veterinary Science Department at the University of Idaho. Prior to that, he served as professor in environmental physiology in the Animal Sciences Department at the University of Arizona. His areas of expertise include environmental and lactation physiology, endocrinology, and molecular biology. I'm now pleased to turn it over to Dr. Collier to introduce and share the key findings of this paper. Dr. Collier.
Thank you, Kent. And on behalf of the task force, I'd like to thank you and the board for the opportunity to address really a critical area of interest to the American consumer with special reference to the use of hormones in food-producing animals. Can I have the next slide, please? I first want to introduce the task force members. In addition to myself is Dr. Hernandez from the University of Wisconsin-Madison, Dr. Jimena Laporta from the University of Florida, Dr. Jim Lauderdale, retired from Upjohn Pharmacia, Dr. Zachary Smith from South Dakota State University, and Dr. John Vicini of Bayer Crop Science. We'd also like to thank the reviewers. Dale Bauman, retired from Cornell University, emeritus professor, Dr. Garth Boyd, the Context Network, and Dr. Jeffrey Dahl, University of Florida. We thank the reviewers for their considerable help in editing and finalizing the document. Could I have the next slide, please? Today, we'll give a short overview of our report, and those components will include a historical perspective, the background of the use of hormones in food animals. We'll also talk about what hormones are and how they're used in food animals. We'll discuss the regulatory framework for drug approval and food safety. We'll speak a little bit about the residues of hormones and how they're monitored and evaluated for safety, and then we'll have a summary. Next slide. Since the end of the Second World War, the United States has pursued a policy of cheap, abundant, and safe food. And as you can see from this slide, this policy has been very successful, with the percent of disposable personal income spent by Americans on their food declining from about 17% in 1960 to about 10 cents today. And that's both food at home and food away from home. Just as a comparison, in the European Union, the average consumer spends 20 cents of their personal income dollar on food, and in African countries, it would be as high as 70 cents out of every dollar. So Americans truly enjoy a cheap and safe food supply, and this policy is largely been enacted by a partnership with the land-grant university system of the United States, where research is rapidly transmitted from the laboratory to the farm with the aid of allied industry and government regulatory agencies providing oversight. Next slide, please. A key component of this ability to reduce the cost of food in the United States has been the explosive growth in agricultural productivity since 1948. As you can see here, the actual U.S. productivity growth has tripled since 1948. And the amazing thing for agricultural production is that our producers held the input costs basically the same. And so the important issue here is one of the major reasons our food supply is so cheap is because the producers and ranchers and farmers have basically tripled output while holding their input costs basically the same. And this has been, this actual graph published by the Economic Research Service is for all of agriculture, both plant and animal. So it's been a truly remarkable achievement on the part of American agriculture. And I might also point out that agriculture as a sector stands alone in being able to accomplish this. In all the other economic sectors of our economy, if you're going to dramatically increase output, you have to increase input costs. So a valid question would be, how did American producers on our farms and ranches triple their output while holding their input costs basically the same over this time period? Can I have the next slide, please? In plant agriculture, this has been achieved through improved genetics and most recently genetic engineering, improved cropping practices, land management, the use of fertilizers and herbicides. In animal agriculture, there's also been a rapid improvement in genetic progress in our animal populations, as well as improved nutrition and reproduction, but also the use of endocrine regulators. This includes hormones and hormone agonists, or synthetic compounds that act like hormones, and antagonists are those compounds that block the action of a hormone. And in particular, these have provided growth enhancing and lactation enhancing capabilities. Next slide, please. So what are hormones? Well, hormones are chemical messengers produced in one type of cellular tissue of an organism, transported in tissue fluids to regulate a specific set of cells or tissues in another part of the organism. And there are several types of hormones which are shown here. If you look in the upper left, we have a peptide hormone, in this case insulin. Peptide hormones are made up of amino acids in a specific sequence, and the size of the molecule depends on the number of amino acids, which varies considerably between different types of peptide hormones. The specific sequence of the amino acids give it a specific shape, and that's critical to allow the hormone to bind to its specific receptor and carry out its function. Now, just to the right, we have what are called amine hormones that are produced from the amino acid tyrosine. You see one group of compounds that are produced from tyrosine or thyroxine or thyroid compounds produced in the thyroid gland. And another group are the catecholamines, epinephrine shown here, and norepinephrine, which are produced in the adrenal gland and which act on a variety of tissues in the body to control metabolism. In the lower left, we have prostaglandins, which are basically produced from fatty acids, and these are very powerful compounds produced by a number of tissues throughout the body. And most importantly for agriculture, plays an important role in the regulation of the reproductive cycle. And then finally, in the lower right-hand corner, we have the steroid hormones, which have a typical structure here. Ring structure is shown in these four compounds. Cortisol in the upper left, dexamethasone, another glucocorticoid to its right. In the lower left is testosterone, and then to its right is estradiol. These are lipid-soluble compounds, which means they can cross cell barriers, and so steroids tend to be orally active, and peptides, on the other hand, which are water-soluble and not fat-soluble, do not cross cell membranes, and typically peptide hormones are not orally active. So we have to inject insulin if we want to see its effect. And peptide hormones, if consumed, are just going to be digested in the digestive tract because they can't cross out of the gastrointestinal tract into the body. So this provides a level of safety for peptide hormones, whereas the steroid hormones are orally active, and we have to pay special attention to their ability to cross cell barriers. Next slide, please. Beta-adrenergic agonists are these are synthetic analogs of the amine compounds. Agonists mean they act like epinephrine and norepinephrine, and they bind to a specific receptor, the beta receptor. And you see there are a number of compounds here that are being used in animal agriculture, which include ractopamine, somaterol, clenbuterol, salbutamol, and zolpidem. Next slide, please. Then we have steroid agonists. These are synthetic compounds that resemble steroids, and they have activities associated with steroid molecules, and those include trenbolone acetate, melangestrol acetate, and zeranol. And as I pointed out earlier, these compounds are soluble in lipid and therefore cross cell membranes and are orally active. Next slide, please. Now, if we look at the chronological sequence of the FDA approval for these compounds, these hormones, also called repartitioning agents, because they change the flow of nutrients from body fat accumulation to muscle accumulation. We can see that the full chronological sequence is in the report, but the first approval occurred in 1954, and there have been a wide variety of compounds subsequently approved that are in use in animal agriculture today. All of these products have undergone rigorous evaluation by regulatory agencies before they were allowed to be used in animals. And all of these products undergo regular reevaluations to ensure animal and food safety remains unchanged. These evaluations are carried out by the FDA Center for Veterinary Medicine and the World Health Organization Joint Expert Committee on Feed Additives. And so on a regular basis, you'll see reports on the most up-to-date information on the food safety of these compounds. And these have are a continuous process as long as the compounds being used in the marketplace. Next slide, please. Well, what agency is responsible for drug approvals and food safety? The Food and Drug Administration Center for Veterinary Medicine is an essential component of evaluating the animal and human safety. We also have the USDA Center for Food Safety and Nutrition, or CFSAN, the USDA Food Safety and Inspection Service, or FSIS, the USDA Animal and Plant Health Inspection Service, APHIS, the National Oceanic and Atmospheric Administration Fisheries Administration, which evaluates compounds used in fisheries, the Environmental Protection Agency to look at any environmental impacts of compounds, and then the World Health Organization Joint Expert Committee on Food Additives. Next slide. Now, at the FDA, there's a very systematic and careful evaluation during this drug approval process of looking at both target animal safety and effectiveness, as well as human food safety. The target animal safety is going to look at whether there's any harmful side effects of compounds, and they will also want to establish a margin of safety or a dose range that can be safely used in animals. And also, they have to establish that it's effective, that it produces a desired response when used according to label, and therefore would be economically advantageous to the producer to use that product. We also have to establish human food safety. That includes toxicology, residue chemistry, microbial safety, and also what analytical methods are valid for detecting residues and following these compounds in animals. Next slide, please. In addition to the prior stages, we also have the requirement to go through chemistry, manufacturing, and control approval, which you will establish what ingredients will be used to make the drug, where did those ingredients come from, where is the manufacturing site, how it will be made specifically, how it will be packaged, how it can be stored and under what conditions, and how long it can be stored, because this will help in determining the drug expiration date. And finally, there's an environmental assessment. And this assessment requires that you have to establish if there's any impact on the environment when this product is used or manufactured. Next slide, please. So human food safety is assured for analogs of natural hormones from studies that adequately address the toxicology, mutagenicity, 90-day feeding studies, reproductive, any adverse effects on the reproductive tract, any teratology, or any special studies that might be identified when in the progress of this evaluation that something is noted, then they'll do special studies. Target animal metabolism, which includes also rodent comparative metabolism, so both metabolism in the animal and also in rodent model. Target tissue studies, looking at where do residues of this compound concentrate, and then looking at marker residues to make sure that you can establish safe concentrations and whether or not a withdrawal time is needed, so that residues are depleted below a safe concentration. Next slide, please. So in reproduction management, each product that's in use has been granted regulatory approval within each country where it's sold. So in the United States, that would be the FDA Center for Veterinary Medicine, and usually JECFA. And you'll establish during that process an acceptable daily intake and maximum residue level limits on tissues from those animals. You look at the potential for any human exposure. Natural hormones, the concentration needs to be below that deemed consistent with human food safety. And this is always in reference, since it's a natural hormone, to the actual production of the hormone in humans as well. And analogs of natural hormones that don't normally exist in nature, then the levels need to be established below the safe concentration for the acceptable daily intake and the maximum residue level. Next slide, please. Growth enhancing technologies have been shown to have benefits. When used in cattle, they increase average daily gain. They moderately alter dry matter intake, which leads to improvements in feed efficiency, or the feed to gain ratio. So responses for average daily gain range from 8 to 28%, depending on the compound, and the feed to gain ratio improvement is 5 to 20%. So a very effective impact on growth enhancement in beef animals. Next slide, please. The hormones that are used in reproduction management, we'll just go through some of these, those that are currently in use. In dairy cows and heifers, there's progesterone, also GnRH, or gonadotropin hormone releasing hormone, prostaglandins, melangestrol acetate, or MGA, only in heifers. Beef cows and heifers, synthetic progestogen, MGA, progesterone, GnRH, and prostaglandins. In sows and gilts, synthetic progestogen, altrinogest, gonadotropins, LH, or luteinizing hormone, and FSH, or follicle stimulating hormone, GnRH, prostaglandins, and oxytocin. In ewes, progesterone and prostaglandins are used. In poultry, there are no hormones given to poultry. And I just want to emphasize the use of hormones in reproductive management is by and large dictated because of two issues. One is these industries have gone largely to artificial insemination, which requires that estrous cycles be synchronized in order for animals to be successfully bred. And because males, especially in the dairy and beef population, bulls are considered fairly dangerous to the producers. Removal of the bull from the farm has improved safety for the producer. But another reason that you want to use these compounds is to accelerate the rate of genetic progress. And this has been successfully accomplished since the introduction of artificial insemination in the late 40s. One final comment I would make is it's important to remember that when you see hormone-free chicken labeled in the store, that is an oxymoron, because number one, all poultry have hormones that are naturally produced by the bird itself. So there is no such thing as a hormone-free chicken. And second, there are no hormones used in poultry management. And so the implication that somehow some poultry in stores has come from animals who have been treated with hormones simply isn't true. Next slide, please. Bovine somatotropin has been used as a lactation enhancement tool. And with BST, it was approved in 1993. It's been in the marketplace now and continues to be in the marketplace for over 30 years. It's naturally produced by the pituitary gland to regulate growth and lactation. A synthetic or recombinant version of the hormone was produced on a large scale to allow producers to improve milk yield with the injection of somatotropin. Concentrations of BST milk are undetectable by most analytical assays, but when it is detected, it's extremely low and not altered by the use of recombinant BST. Concentrations of IGF-1 or insulin-like growth factor 1 in the milk of recombinant BST-treated cows are within the physiological range of untreated cows and less than that found in human milk or human saliva. BST does not elicit a biological action in humans, whether orally administered or injected. And milk from RBST supplemented cows is indistinguishable from milk of non-supplemented cows. So it's been well established that milk from dairy cows treated with recombinant bovine somatotropin is safe. Next slide, please. Oxytocin is a hormone that's released by the hypothalamus, the posterior pituitary, and elicits a milk ejection response by causing contraction of myoepithelial cells in the mammary gland. In humans, it's used for both stimulation of labor and milk ejection. In dairy cows, a synthetic form of oxytocin is used to stimulate milk ejection reflex, and it's also used for mastitis therapy. FDA regulations allow the use of injected oxytocin in livestock. It's very rapidly metabolized, and there's no apparent risk of residues occurring in milk. Next slide, please. So if we look at the use of these compounds and residues, for the naturally occurring compounds, we have acceptable daily intake established for humans, shown on the left of this table, for estradiol, progesterone, and testosterone. Since these hormones are naturally produced in humans at much higher concentrations than would ever be observed or detected from animals that have been given any of these hormones, there's currently no specified residue for liver or muscle for any of these three hormones. For the synthetic compounds, we do have residue limits established, and they are shown here, the 10 micrograms per kilogram of liver, and for the muscle, for trenbolone and zeranol, it's 2, and for melangestrol acetate, it's 1 microgram per kilogram of tissue. Next slide, please. We've also established beta adrenergic agonist maximum residue levels for clenbuterol, ractopamine, and zolpadrol. Remember, these are synthetic compounds that mimic the action of epinephrine, and they bind to the beta adrenergic receptor. And you can see here that these residue levels have been established for these three compounds. And these are regularly monitored by the surveillance branch of the Food and Drug Administration. Next slide, please. To summarize then, use of endocrine regulators to improve efficiency of growth, lactation, and reproduction has contributed significantly to providing a safe and low-cost food supply to American consumers. The intense regulatory scrutiny required to approve these products for use in animal agriculture has also contributed to the safety of the world's food supply. For naturally occurring hormones, the FDA has concluded no physiological effect could be expected in consumers eating animal products containing additional amounts of that hormone that is less than or equal to 1% of the amount produced by the human daily. None of the approved naturally occurring hormones in use produce residues that surpass this target level. Next slide, please. For synthetic compounds, the use of production enhancing technologies is heavily regulated in the United States and across the world by multiple agencies, resulting in an extremely safe food supply. Adverse health effects in humans associated with correct label use of approved products is virtually unknown. Furthermore, they have contributed substantially to reducing the carbon footprint of animal agriculture by reducing nutrient requirements per unit of productive output, whether that is meat or milk. That concludes my presentation, and the task force and I are now happy to take questions.
Thank you, Dr. Collier, for that excellent overview of the highlights and some of the key information from the paper. We are receiving several questions we'll begin to address with our panel of subject matter experts here in just a few minutes. As we prepare for those questions, let me share some information about our upcoming releases. On August the 25th, we will be releasing another CAST issue paper on agriculture and the microbiome. The co-chairs for this paper are Dr. Ignacio Carbone and Megan Andrews from North Carolina State University. And then in September, we will release another commentary paper, The Importance of Communicating Empirically Based Science for Society, with the chair of that paper, Dr. Stuart Smythe, Associate Professor, College of Agriculture and Resources at the University of Saskatchewan. Please join us for those webinars to get some additional information about those particular topics. Next slide, please. Once again, let me welcome back our presenter, Dr. Collier, and our additional panelists, Dr. Jimena Laporta, Assistant Professor of Mammary Physiology at the University of Florida, Dr. Laura Hernandez, Assistant Professor of Lactation Biology at the University of Wisconsin-Madison, Dr. Jim Lauderdale, retired executive with Upjohn Pharmacia, Dr. Zachary Smith, Assistant Professor of Ruminant Nutrition at South Dakota State. Thank you all for joining us today. And Dr. Collier, I'm going to turn it back to you to begin to answer or respond to some of the questions that are being presented through our chat.
Good. Do you want me to take this straight from the top on the questions?
Sure. Just taking whatever you feel well appropriate.
All right. So the first question was: is there a breakdown by income bracket for percentage of total income spent on food, and if so, are there significant differences between the bottom 20% and the top 20%? And I would direct the person asking this question to the report, which is available online, the Economic Research Service. My recollection is that that's the average for all consumers. So I did not see a breakdown by income bracket. To answer your question. Okay. I'm trying to scroll down through here. I had one correction. CFSAN is FDA, not USDA. And I stand corrected there.
I think, Dr. Collier, we pulled up some of the key questions into that Google Doc as well.
Let's see here. I have to get access. Excuse me. Could you read off the first one while I try to access my Google Doc here? So did you, can you access a question for me then, Kat, while I pull this up?
Juan, if you open up Delana Louette's microphone, she has the Google Doc up, and we'll read the questions, and then we'll let people respond to them. I know it's supposed to be.
Delana, you should be unmuted now.
One of the second question was, how often have impact assessments found significant hormone release to the environment? What has been the most serious case recognized so far?
This is Zach here. I could probably answer the first part of that question. A lot of this has to do with the excretion metabolite. So some work recently conducted, and it's published in Agricultural Ecosystems and Environment. It's from the Dr. Phil Smith lab, and it's Sandoz et al. 2017. And they went and looked at, they're based out of Lubbock, and they went around the panhandle of Texas and posted up at different playa wetland areas within 15 kilometers of feed yards. And of course, the beta metabolite of estradiol and trenbolone, those are the anabolically active components. And it's the alpha metabolite that is excreted via urine and through bile and feces. And they found in about 16% of the sediment samples, they found alpha estradiol, which is not anabolically active compound, and they were not able to find any synthetic androgens in any of the sediment samples that they collected from any of the playas there in the Texas Panhandle. I'll digress for the second part of this question.
What was the question?
The second part of the question was, what has been the most serious case recognized so far?
Incorporated in that question is an assumption that there's been seriousness. So this is Lauderdale. Every compound that's been approved has had to go through an FDA CVM assessment for environmental impact, both at the manufacturing site and at the on-farm use site. And so as Dr. Smith indicated, the target animal materials that are metabolized and come out of those animals are followed and identified as to whether or not they have a negative impact on the environment. And no product is approved if it has a negative impact on the environment. So another way of answering the question is there have not been any serious negative environmental impacts as a result of these products.
Okay. The next question is, how much hormone is excreted with potential environmental impacts? Given that there are no hormones used in poultry, could you comment on labels suggesting otherwise?
This is Bob Collier. I think the author of that question recognized that I did comment on that. Relative to the first part of the question, how much hormone is excreted with potential environmental impacts? Remember, animals are producing hormones on a regular basis and always have been. So it isn't likely when you look at natural compounds, it's going to be any real change in the amount of excreted hormone. In other words, it's going to be within the range of normal values that would exist for that hormone in a given species. For the synthetic compounds, I am not aware of any large-scale studies that have looked at long-term environmental effects from residues in waste.
The next question is, have there been any studies with comparing excretion rates with natural hormone rates in plants?
And I think that was in reference to phytoestrogens. And so in other words, if animals are consuming phytoestrogens, is the excretion of estrogen-like compounds going to be on the same scale? And I think that you would be very, it would be very difficult to show any real change with natural hormones, but I'm not aware of large-scale studies done with the synthetic compounds.
If I may offer a different perspective, the issue is not how much or how little. The issue is, will the excreted materials or metabolites of the excreted materials have a harmful effect on the environment? And the answer is no. And the answer is no, because those environmental assessment studies are done from every single product that's approved.
Okay, there's a question on, can someone provide links to official confirmations of the assays detected eliciting biological effects? Those are in the FDA links that are in the reference section of the report. And the next question, can you comment on the use of BST to increase animal well-being and welfare? And there have been a number of studies done, but there's no approved use of BST to improve animal well-being and welfare. And I'm thinking in terms of transition cow diseases were evaluated, and some other metabolic issues were evaluated, but no company has achieved an approval for that use in animals, so it's not something that could be advertised. You'd have to get a claim approved in order to do that. The next question, what is the range of naturally occurring hormones between different individuals, animals, and different breeds of animals? What we have provided in the report is the normal production rates for these hormones in humans and what might be expected so you're looking at 1% of that is going to be much higher than the concentration of any of these hormones in animal tissues. Any other members of the task force want to comment on that? Okay, next question. Are there surveys that have queried the extent of use of hormonal supplements among livestock producers? Zach, I believe you had some information on use of
At least for steroid hormones, I do. APHIS would have done a survey back in.
Did we lose Zach? Did we lose Zach?
I believe so. Do you want to cover
It's weird because Zach is unmuted, and he's showing here in the list of participants.
Can you unmute him?
He is unmuted.
Okay. Maybe he lost lost his internet there at the airport. So.
Move on to the next question.
Okay.
He fell off.
Okay. Does increase in use of exogenous hormones, does that not contribute to the increased cost of production? Well, typically, if you're going to introduce a product into animal agriculture, for every dollar that's invested, you'd need at least a 3-to-1 return. And for the beef industry, and Jim Lauderdale, you can correct me if I'm wrong, but it would have to be at least 5-to-1 return on investment. So there is a slight increase in cost, but the gain in productivity far outweighs the cost of use of the product.
I agree with you, Bob. And one additional piece of information, since Zach got lost, is that as an example for MGA, it's used in about 80% of the feedlot heifers in the United States. And it's used only because it's efficacious and returns a positive return on the investment. For the other anabolic agents in the feedlot industry, they're up in the 50 to 70% range. For reproduction use, unfortunately, in the beef industry, it's down between 15 and 20% because of the small size of herds. And for dairy, I think it's more up in the neighborhood of 50 to 60%.
Zachary, Dr. Zachary Smith is back and unmuted.
I'm back. Sounds like Dr. Lauderdale wrapped up the question.
Yes, he did.
Thank you.
Next question is, what types of current research are ongoing to optimize the use of hormones? I would say these companies that market these products are always looking at ways to optimize their use, either through the improved delivery methods or alternative ways of producing the effect by not so much routed delivery as by coating or other types of release control mechanisms.
Yeah.
Most of that is ongoing through industry and not universities.
I would agree with what Dr. Collier just said. You know, one thing we found out in the last maybe 5 or 6 years was, well, one, we've had these coated implants on the market since 2007, and there's been about 3 or 4 more released. These allow a single application of a steroidal implant in the animal up to 200 days before it's harvested. The other thing would be is that we've become a lot more judicious in the use of these compounds, and so instead of using sequential, more equal potency implants, we figured out that we can use less potent implants initially, and then follow that up with a more potent implant and get the same effect in regards to growth performance as using 2 more potent implants at once sequentially, without any negative repercussions on carcass weight, and we actually are able to improve carcass quality. And all these would have been determined out in the field by practitioners, and then subsequently confirmed in large pen research facilities.
Second part of that question is, are there any impacts of MRLs on animal agriculture trade? And I'm not as aware of how much our trade with specific countries in meat products is affected, but I don't believe there have been, I don't know how much of our beef industry products are shipped right now. I don't know what the export market is. Does anybody else know on the task force?
been involved in those discussions for about 35 or 40 years. The question specifically, do MRLs have an impact? The answer is no, they do not. They're very positive all over the world. The challenge is that some countries choose to use a precautionary principle that says if you're not absolutely safe, you're not absolutely accepted. And so a number of products are banned, and they're banned based on a country decision. We're not going to allow these in. And so those countries have very stringent testing facilities for shiploads of beef that arrive at their shore. And if they're contaminated, they reject them.
Okay. Next question was, given the impact of COVID-19 on the food system, are practices being modified? What are the impacts on production goals? Kent, there's a report that's been put together on COVID-19, correct?
Yes, we released that about a month ago. A group of economists looked at, particularly how it was affecting everything from consumer trends to, the meat markets and wholesale markets for lots of products. So that is available on our CAST site as well. I guess the question would be is amongst the five of you, maybe what have you observed as it relates to the use of these types of products in cattle? What are some of the, or not only cattle, but in other forms of livestock? What are you all seeing in terms of the use of these types of products? Has COVID-19 affected that at all?
I guess I could comment some on at least on the dairy side of things. Initially, there was a kind of a run to decrease production because we weren't able to sell milk. And producers were looking at ways to optimize their rations and the products in terms of not having to dump milk and losing their herds. So they were taking some things out, keeping some things in, and also they were working on trying to decrease the production and keep the cows in the herd maybe longer without potentially affecting their next lactation because of the inability to sell milk, particularly early on. So I would suspect that there was probably some decreases on things. I don't know how large that impact was or how sustained it was, but they were, at least in Wisconsin, they were rushing to try to decrease production because people were dumping tankers of milk. And a lot of farms were closing, at least within our state.
I could comment on the beef, finishing beef side of things. There were two things. One, you would not have expected. The other was quite anticipated. So for example, with the use of a beta adrenergic agonist, and in the US that's ractopamine, it's fed for the last 28 to 42 days. And once you start that compound, you don't stop and restart. And so when we were running into issues with getting cattle scheduled, we were talking to the plants 50 days ahead of time, and they'd tell us, well, we'll put you on the list. The use of ractopamine was discontinued by a lot of feeding entities unless they had a guaranteed spot for those cattle to be harvested. Our recommendation through this whole deal was to actually continue implanting cattle if you had the facilities to handle the cattle at a more advanced weight. The reason being is because estrogen actually causes long bone growth in the steer. And so if we were to go naked without an implant there in the last 30 or 40 days of the life of that animal, we were going to run into some issues with really poor feed conversion efficiency, and those animals were going to get fat a lot quicker without having that implant in their ear. And so our recommendation through this whole deal was if you had the facilities and the labor and the ability to do so, that implanting a steer that you're going to keep around an extra 60 days wouldn't be a bad deal, is at least what we were thinking. That animal wasn't going to get fat, and we could still have an acceptable level of rib fat on that animal when it came time to harvest it.
Dr. Collier, I think we've got time for one more question. You can pick which one you think and direct it to somebody maybe on.
We had, real quickly, RBST is still approved. It's still in the marketplace. I don't know the percent of animals that are actually being treated, but it is actively being marketed. Does the use of exogenous hormones create dependency? And the answer to that is no. What are the biological effects of phytoestrogens when ingested by humans? And again, that's, as in everything, is dependent on the dose. So anybody want to comment on the phytoestrogens question?
I would love to. Those who consume large quantities of soy, mostly weightlifters, generally have breast development in males, and that's direct effect of the phytoestrogen in the soybean meal.
Okay. I think,
Thank you. Thank you to Dr. Collier and all of our panelists. We have noted all the questions, and if we didn't get your questions, we're going to circulate the full set of questions to the panelists, and if we can get those questions answered, we'll produce a follow-up to this, a document that we can post on the CAS website that will have some of those. Again, just a reminder, if you've not seen the paper yet, here's how you get it. It's on the CAS website, and you see this address. And also, if you have a specific follow-up with one of our presenters or panelists today, here are their emails. They graciously agreed to have them shared that you can follow up with them individually. Again, thank you for being here. Thank you for joining us today. I would invite you to please join us for some of our upcoming webinars, the one that we have in August, on August 25th on microbiome and agriculture, and as well as the paper that we have coming up in September on the importance of communicating empirically based science for society. Those will be produced in webinar format and very similar today. I would also like to acknowledge, thank our friends at Dairy Management Inc. for their assistance in helping put on this webinar and us being able to present this information with you today. Thank you for joining us and have a great day. Thank you.